Hi, my name is Evan Machin Finch. My student number is 3943340. With this assignment, submission for the 3B video project task, I selected a rectangular hollow section of a steel beam. This was located in my garage, my house. I chose it because I think RHS beams provide really great strength to weight ratios, particularly for their bending resistance due to the high moment of inertia. So this structure is really performs really well under the circumstances it's in as one of the pylons in a garage setup. The beam is 3 meters long with a width of 100 millimeters and a height of 300 millimeters, and the inner wall thickness was 20 millimeters. So it's a pretty sturdy structure. It's simply supported at both ends, and a concentrated load of 60% was applied along the span, which replicates like a realistic scenario in terms of the load that it can come under. So again, for a garage, a carport beam with a load from a vehicle isn't perfectly centered. So yeah, and then this leads to my calculations. So we had the maximum bending stress. So I'll try to show the sketch here. So it's on my phone, so it's not perfect, but there it is. Not sure if that's hard to read, but you can see it in the submission file upload. We had calculations got us a MPa of 11.75, so that's the maximum bending stress they can endure, and they occurred from the left-hand supports. Yeah, and then we had maximum shear stress bending, which we also had to find. Again, I apologise for the camera setup, but this is all I got right now. So is it there? Diagram at the bottom, hard to read, but again, this is all in my file upload. So again, we found the maximum shear stress that our steel beam could withstand on a bending. That led to 3.0 MPa, that calculation confirmed that the steel beam can resist well within the steel beam's capacity, which was really good to find out, which obviously we expected as well. And then the next calculation was principal stress, which again, these are all in my file uploads, but I'll just show you for the sake of it. Very hard to read. So for the principal stress, we used Mohs circle to create a diagram which showed all the axes, which are again shown there. And that showed us how bending and shear stresses combine internally at point based on the values that we get. So the failure angle, we found a failure angle of 13.5 degrees. That was what we used. And we knew that the maximum in-plane stress was 6.60 MPa. So we used this to find our principal stresses. So maximum principal stress O1 was 12.47 MPa, and minimum principal stress, so like when it's most compressed, was negative 0.72 MPa. That leads us to our final calculation, which is maximum in plane shear stress. Maximum plane shear stress. Apologies. Oh yeah, so that was sort of described. That was our maximum plane shear stress, which was 6.6 MPa. And yeah. Then final reflection for this task. I think the project was, for me, really good because I definitely lacked understanding on VP task 2. I think my loading calcs weren't great, so it was really important that I was able to sort of, hopefully learn from that and improve for this one. It's great because it's got like real world beam theory, which is obviously I'm interested in. This is the structure I chose was a steel beam in a garage, so it's applied to the real world, which is really interesting. But yeah, one of the key challenges was the initial loading location was incorrect. So that was my mistake, which costed me a few marks in that task, which was obviously needed to be amended. So this correction meant that my bending moment, shear force, and like dependent stress values were wrong, which is critical. So yeah, that highlights how sensitive the calculations are and how, it's really important to ensure that your calcs are on, because these are come down to decimal places. It's very specific. But overall, this assignment helped me learn how to create better diagrams and read diagrams for beams. Perform stress analysis using Mohs circle for visualization, which was really a good learning experience. And yeah, learning about safety margins for real world planes. That was really good. I feel much more sort of capable of evaluating the beams now after this task. To learn how to make sure a beam's safe under complex loading scenarios. Yep, thank you. Cheers.